let's go ahead and knock this out of the way so that we can talk about 17B stuff. And just as a reminder, if there's ever something that you for sure want to see me go over in class, you can always add it to a discussion in Canvas. You can shoot me an email. You can send me a note through Canvas. Or if you fill out the weekly reflection form, that's always going to have the option to give me ideas about what you'd like to see in class. So this was a special request, and let's dive in. So if this is your first quarter with me, I'm all about let's get as much partial credit quickly on a problem as we can, because sometimes the way we earn grades on tests is racking up points rather than completing every single problem perfectly. So the moment that I see a tangent line, I'm going to demonstrate that I know what I'm looking for and dump in as much information that doesn't require calculus as possible. So I know that we're doing this at x equals 0, which means I can find the y value at x equals 0. And if I plug in 0 here, 2 times 0 is 0, and e to the 0 is 1. So my y value is going to be -1. I'm just going to pop that in right now. Y minus -1 equals m times x minus 0. And then I'm going to write a note to demonstrate I know what I'm supposed to do. Now, even if I mess up the calculus, I'm going to get a bunch of partial credit for this. Now, let's actually do the thing that we're supposed to do. So I know I need to take the derivative here. Derivative of 2x, I'm looking at 2. E to the x, derivative is the same as the function itself. And I've got e to the x. So I know that if I now plug in 0, I'm going to get 2 minus e to the 0, or 2 minus 1, and my slope is 1. So over here, I'll go ahead and plug that in, maybe switch this around to say y plus 1 is equal to 1 times x minus 0. And if you want that to be in y equals mx plus b form, it's just a quick bit of algebra to rearrange this. And that's it. I know that was a bunch of words, but I am asking us to sketch a picture, and then we're going to use geometry, not calculus skills. We're going to use geometry to find the area that is under the line y equals 3 minus x, that is also above the x-axis and in the first quadrant. So all I'm going to ask you to do on your paper right now is to just sketch this line. So hopefully your sketch looks something like this. I know this is a line with a y-intercept of 3, a slope of -1, which means it's going to cross at 3. And if the slope is -1, it's also going to cross at x equals 3. So the area that we're talking about that is above the x-axis and in the first quadrant is really this triangle right here. Go ahead and find the area of that triangle. And if you need help, I bet there are other people in this room that remember the formula for the area of a triangle. Numbers 4.5, 9/2, however you want to look at it, works for me. Will someone be brave and tell me what they used in words as a formula for the area of a triangle? Okay, that'll work. Base times height all over 2. So in terms of this triangle, I've got a base of 3, a height of 3, all over 2, we got 9/2. Okay, our objective today is for no reason at all to make this a much more complicated problem and still come up with 9/2 for an answer. Okay. Now, what other nice geometric shapes should we be able to find the areas of? I claim triangles are on that list. What else should we be able to find areas of just like using formulas from geometry? Rectangles, what else? Sure. How about circles? Should we be able to find areas of circles? I'm going to go with yes. We should know what the area of a circle is. What's the formula for the area of a circle? Cool. So you already know, right? Other geometry formulas that we probably ought to know how to find the area of include trapezoids. And I'm just throwing those out there because those are the nice shapes that we spend some time in geometry figuring out areas of. Now, if you had a really great Algebra 2, geometry, math 2, 3 instructor somewhere in that realm, you might have also had a geometric formula for finding the area of any regular n-sided polygon. If you didn't, there is a homework question that's kind of leading you in that direction. But so those are all the nice things that we know how to find the areas of. But we've been dealing with a lot of other less nice functions in calculus so far. And they don't even have to be a whole lot less nice. Just a little bit less nice. So I'm thinking about things like, I'm going to keep it simple here. Y equals the square root of x. If I wanted to look for part of the area under this thing, like maybe I wanted to come out here to x equals 25, and I wanted to look for the area under there, it's not exactly a triangle. It's definitely not a rectangle. It's certainly not a circle or a trapezoid. So, gonna let you in on a little secret. Mathematicians are like to minimize effort and maximize accuracy. I was gonna use the word lazy, but I'm not. I'm gonna say minimize effort, maximize accuracy. So what might that look like if I walked up to this and I was like, well, I kind of want to estimate the area under there, but I don't want to have to do too much work. Easy thing, maybe I just turn that into a triangle. Is it particularly accurate? If I were to just draw a straight line there and find the area of the triangle? Most unfortunate. We're trying to minimize effort, but maximize accuracy here. So I know you all already saw some of this in class yesterday, so I'm not going to bore you all for too long. But here's how I'm going to choose to estimate that. Well, I'm going to make you all do the work. What are some nice numbers that we can take the square root of? I heard 9. I'll take a 9. 16. And I'm going to go with 1 also. So what I'm going to ask you all to do, I'm going to draw this in. And I'm going to draw in some rectangles, but I'm going to make strategic decisions around the heights of my rectangles. And I'm going to ask you to estimate the area using 1, 2, 3, 4, 5 rectangles. And sampling numbers for the heights at x equals 1, 4, 9, 16, and 25. Before we go there, based on my picture, When we find the area of those rectangles, will it be an overestimate or an underestimate of the true area below the curve but above the axis? Because all of my rectangles are bigger than what's there. Okay, so I'm gonna label these as like area 1, area 2, area 3, area 4, and area 5. So for that first area, I know I need the base times the height. Well, the base of that first one is 1, and if I want to find the height, this says I'm going to find my heights looking at these particular x values. So at 1, when I plug 1 into the function, I get a height of 1. For that second area, this base is 3. And the height I'm going to get by plugging in 4 to the function. Square root of 4 is 2. So that first area was 1. That second area, I'm looking at 6. For my third area, that base is 5, because that's the distance between 4 and 9. So my base is 5. And the height I'm going to get by looking at the square root of 9, which is 3. So that one's 15. My fourth rectangle, 9 to 16, that looks like 7. So my base is 7, and my height is going to be the square root of 16, or 4. That looks like 28. And for my fifth rectangle, that base is 9. And that height I'm going to get by the square root of 25, which is 5. 9 times 5 is 45. And if we add all of those up, let's see, 45 and 15, that's 60. Now I'm at 88, 89, 95. So I think our area estimate is 95. Did we have other choices for how to break up those rectangles? Heck yeah, we did. But I chose convenient numbers because I had a square root of x. I'm going to warn you, we're not always going to get convenient numbers. So what would have happened if we had taken that same graph, but broken our rectangles up differently? I'm going to flip the page. Anyone? I see people still writing. I'll pause for a second. Talk about other things. No, all good. And just as a reminder, I post the notes after class. If you ever miss something and you're going back to look for it, in Canvas, there's the link to my Google Drive folder with all the notes from class. Okay. So I'm going to go back and take that same picture. And it's still going to be at x equals 25. My function is still the square root of x. But this time, I'm going to use 4 rectangles and left hand endpoints as sampling numbers for the height. So first of all, if I have 4 rectangles, I have already given us not a nice number, but it's okay. We can handle it. We can handle fractions. So right now, if I'm looking at this area from 0 to 25 and I break that up into 4 pieces, I promise not to make you talk, but stick your hand up when you know how wide each piece is. You can leave it as a fraction. If you prefer decimals, that's okay too. Promise not to make you talk. Just looking for the width. Let me see some hands. How many people know what the width is going to be of each rectangle if I break that into 4 pieces? Cool. I'm going to ask a different question. I'm going to make it nicer. And then we'll go back to this one. Pretend I had said we were going to use 5 rectangles. Stick your hand up when I promise not to make you talk. Stick your hand up when you know how wide each rectangle has to be. If I break that into 5 pieces, I had more hands. Keep your hand up if you're brave enough to say out loud how wide each rectangle is going to be. Oh, like almost every hand melted. Hi, I'm Sarah. You are? Gia. Gia, sweet. What were you thinking? How many people were thinking 5? Totally. It's 25 wide. I broke it into 5 pieces. 25 divided by 5 is 5. Cool. So here's the thing. If it's 4 rectangles, it's not pretty, but that's okay. The width of my rectangle is 25 over 4. Fractions are our friends. We can leave that as a fraction. It's all good. So I'm just going to break this into 4 pieces. Now, when I say left-hand endpoints as sampling numbers, what that means is this is now, I've got 4 intervals that this is broken into. And for each interval, the place where I'm going to plug in the X value to get the height is whatever's on the left-hand side. So for this middle interval, if I'm looking at this interval right here, then that left-hand side number, that's what I would plug into the function. So that's what the height of the rectangle would look like. For this interval here, I'd plug in the number on the left-hand side. That would be the height of my rectangle. For this one, I'd plug in the number on the left-hand side. That would be the height of my rectangle. Now, all the way on the left-hand side, the height of my rectangle is 0 because that's the X value all the way on the left-hand side. So the base of each of my rectangles here is 25 over 4. So I need to actually know what are the X values we're going to plug in to get those heights. Well, if the width of this is 25 over 4, then that first X value is 25 over 4. What's the next X value going to be? I'll take your 25 over 2. And I'm going to ask someone else to explain where the 25 over 2 came from. Yeah. Totally. And then if we simplify that, that's 25 over 2. You could also have said, oh, that's just going to be the one in the middle. It's 25 wide. The one in the middle is 25 over 2. Okay. How about this one? I know that's the messier one, right? Couple of options. One option, that's exactly halfway between these 2 points. And if I wanted to find that midpoint, it's the average of the other 2. So I could add these 2 and divide by 2. It's not the route I'm going to take though. Instead, I'm going to say, I'm going to pretend I was walking there and each of my steps was 25 over 4. So I had 1 step that was 25 over 4, and then this was 2 steps that were 25 over 4, and this is 3 steps that are 25 over 4. So I would choose to write that as 3 times 25 over 4. By the way, if I did that, my last step over here would be 4 times 25 over 4. And what do you know? That gives me the 25 that we were hoping we would end on. So that 25 over 2, if I wanted to write it so that it kind of looked the same as the others, I didn't need to erase the 25. I could think about that 25 over 2 as 2 steps that were 25 over 4, and then just simplify the 2/4. Good news. You don't get a calculator on your quizzes or tests, which means you don't have to do the math. So when I get to this next step where I'm actually looking for the area, it is totally fine to leave this area as looking like, well, that first piece had a height of 0. So I'm just going to write that as 0. That second piece had a base that was 25 over 4. And then we need to plug the 25 over 4 into the function. That next one had a base that was 25 over 4. And the x value was 2 times 25 over 4. And that's what I'm going to put into the function. And that last piece, again, had a base that was 25 over 4. And the x value that I'm going to put into the function is 3 times 25 over 4. Yes, a bunch of that could simplify, but we don't have to. We could just walk away and leave it like that. I did kind of a messy one, I know. Should we go back and do a less messy one?